If you have an engine like this, or you have a road tax or any type of four-stroke engines that you're not sure about, you feel free to give me a shout. My information is at the end of this video. I've been involved with aviation for about 15 years. I'm an aircraft mechanic, predominantly on helicopters. But I'm always willing to help out and educate however I can for free, so you don't get yourself into trouble. If you're really not sure about something like this, I do not recommend you doing it unless you have a mechanic background or you've got somebody that you can go and do this with that you know is a proven mechanic. Hope you enjoyed the video. I appreciate you watching. Take care. Hey guys, this is Brian Goff here from Paraflight. I'm tearing apart a Hellcat engine. One of the overhead cam cogs sheared. As far as I know, it's the first one that's ever happened to. I don't recall or have in research found any other engines that's had this problem. This engine sat for about 5 years. I did scope it with a camera before I started it, and I cycled the prop probably close to 30 or 40 times to pump oil and to move radiator fluid through the system before we fired it up. And within the first 5-6 seconds it was running, the cog let go. And it could have just been a defective part. And basically what it comes down to is pulling the overhead cam and replacing the piston. And here's a picture of what that looks like. This is the cog off of the right side of the Hellcat, and you can see that the gears have sheared. You can see that the chain cog is spinning free from the crankcase cog. So that is our culprit. So here's the engine, and you got to pull this plate off. The cog is right inside here. I'll show that to you in a minute. And this is basically the piston part of the engine. We just stuff some rags or paper towels down in there so nothing gets down inside of the engine. There's the new piston. Not sure if you can see that with the lighting, but you definitely want to replace the piston if there's lots of gouges or scars from when it struck the valves. And you can see the timing chain hanging out. It's got two sets of timing chain cogs, which are right here, and the holes in the top of that head are how you determine top dead center. That is from the manufacturer. I will definitely test that, obviously, before running the engine to make sure that that is accurate. And then these are the springs, and what the springs look like. You can see they're pretty bent up. And like I said, the motor was shut down immediately after, so luckily it didn't cause any damage. This is the head, and you can see where the valves go into the cylinder head. This is where the timing chain comes up through, and then the overhead cam gears, which are right there, sit on top of this, which is basically how it works. You got your fuel valves and your exhaust valves. So, and then in order to do this job, you really should be mechanically inclined. This is a tool that you need to compress the valves. A lot of people make up stuff. You do need a 14 millimeter compressor, which is this right here, which is what presses the valves in so that you can remove the little shims to release the spring tension. So the job, it's taken me probably about 5 hours as far as tearing down and putting back together. And then obviously run up and break in and whatnot, and a carburation adjustment. So it'll be a total of about 6.5 to 7 hours, all said and done. So after you decompress the springs and you remove these little shims here, which look like this, they're extremely small. They're basically at the very top of the valve. This is what it looks like. So those little shims slip right down in there, and there's grooves on the top of the valve that they sit in. So once you decompress that and you get those shims out, then you can flip this cylinder over, and the cylinder's in good shape, and you can actually pull the valve. Sometimes you got to turn it. You may have to use a flathead. Just be careful not to score. And you can see where the valve came out, where it bent. And again, it bent because the cog sheared inside of the engine, and the timing chain obviously was off. So the piston smacked into the valves, and they didn't close because the timing was off on the chain. So the whole makeup, basically the way the valve sits inside of the head is you've got this little washer here. It's got this little spring on it. I don't know if it comes in real good in the video, but that goes on. That would go down first, and then the spring sits on top of that. So it sits on there like that, and then those little shims lock in to that groove right there. And that's basically all there is to it. And then there's a little bucket that sits on top of that, which is what your lobes hit, and the lobes are these little things in here. So those lobes rotate obviously with the chain, and they compress that bucket, which opens and closes the valves. Now normally there's spacers, and you can see in the bottom of that there's a spacer in there. Most motorcycle or any four-stroke engines that I've ever worked on in the past, they don't have those built into the bucket. You actually have to buy them, and that's also how you adjust the gapping between the lobe and the compression of the bucket. So make sure that you look for those little spacers when you pull all this apart if you decide to take a challenge and do it yourself. Okay, so we've got the head and the overhead camshaft back together. Everything was lined up at top dead center, and the way you tell that is by setting the piston there in the very top of the stroke, and then you have to unbolt these two bolts right there, and those bolts are torqued at 28 Newton meters, which is, I think it's about 21 foot-pounds. So you want to make sure that your slack in the chain is in the top cog here, this one, because if it's in the bottom, the chain tensioner is not going to do its job. So you unbolt in those two bolts, and you don't need to remove them, but just loosen it up enough that you can slide the cogs around to get the chain in there. And again, you just want to loop the bottom one first, and then let all the slack go to the top one, so that you can tension it up with the chain tensioner, which is this bolt right there. And that, I believe, is a 15 Newton meter, which is also in the manual. I'd have to double check again. And then what you want to do is make a little mark. And I have a little scratch mark right there on the plate, and then I put a permanent marker on the crank. And as you can see, as I rotate this the way the prop would rotate, which would be counterclockwise, one revolution, you can see the little green marks on the cogs. I rotate it once, it opens up the exhaust valves, it goes to the bottom of the stroke. As I come around again, my two marks, all three of my marks rather, should line up. So the mark that I have on the crank should line back up, and when I do that, I have these two holes here. There's one right there and there's one down here. I can stick a screwdriver in there, and the piston returns to top dead center. So we know everything was done properly. If it wasn't done properly, the marks that you made on these cogs and the marks that you made here on the crankshaft, when you line them all back up, one of the cogs would be off maybe one link, which is very minor. You just loosen it up and you'd have to adjust the chain and to get everything to line perfectly back up again. I hope that helps you out. If you have any questions, give us a call. Okay, this is the first test after the Hellcat has been rebuilt. We got it primed up, and we'll see what happens here. Everything appeared to go well. Now it's just a matter of the break-in process, and then go fly it.